Hey, hello, and welcome to the show. It is me, John Park, and this is John Park's Product Pick of the Week, JP's Product Pick of the Week. That's the title of it. I was thinking about something else, which was I forgot to go ahead and, let's see if we can shift the, oh, look, it's blue. All right, leave that alone. Wow, what's going on here? Thank you for stopping into the chats, first of all. We have people over in the YouTube chat popping up. Hi there, Tyrone Mix and Beatagraf Abdelhagen, Dave Odessa, Burton R. Hey, hello. The other place to go, if you're wondering where the chat is our Discord server, which is at adafruit.it/Discord. And then look for that live broadcast chat channel right about there. Who's here? Who's in the chat? We have Scotty Beam Me Up, hello. Jim Hendrickson, C. Grover, Byron, Paul Cutler, Sam J. Ohio, Thin Man, hello. Thank you for stopping by. Hey there, Relic SE, jumping over in the YouTube chat. Howdy. So what's going on here is that I want to send you to a place, not that place, that's giving it away, that place. That QR code, that URL, that will take you to the product page for this week's product pick. This show is broadcast from within the product page. That's where I am. Go there. You can watch the show. You can decide if it's something you want. You can throw it in your cart. You can purchase it. We have a big discount on this week's product pick. It is, reloading my page, it's a steal. It's 50% off. You can get up to 10 per customer, no resellers allowed. You don't need a coupon code. However, we don't do back orders and rain checks and things like that. So if you want some, throw them in your cart, buy them, because after the show, the price goes back up to normal. So this is a pretty special moment, a little slice of time where you can save a bunch of money on this week's product pick. What I want to do next is have Lady Ada tell us about this from her new segment, going back a few years on Ask an Engineer. So take it away, Lady Ada.
It's a Circuit Playground Bluefruit. So you get the nRF52840 chip in the center here. That's a 1 megabyte flash, 256K RAM, Cortex M4 running at 64 megahertz. It's got 2 megabytes of QSPI flash over here, so you can use that for storing files, configuration data, CircuitPython code, etc. It's got micro USB, and the reason I stuck with micro USB is so it'll fit the case that we made for the Circuit Playground Express. So it's the same exact configuration for the switches and the buttons. So that makes it so you can reuse this case, which we so lovingly designed with Mike Dole like a year and a half ago. It still has 10 RGB NeoPixel LEDs, just like the Circuit Playground Express. It's got the 2 buttons. It's got the temperature sensor, the light sensor, triple axis accelerometer, PDM microphone, speaker. One thing about the speaker that has changed is that this chip does not have a true DAC. The nRF52840 doesn't have an analog output like the SAMD21. So you can play audio clips out of it, but they're not going to sound as good as the 21, which had like this nice 10-bit audio output. We do PWM output, and you can do like some basic beeps and sound effects, but it's just not going to sound as good as the SAMD21. We have the reset button, and then we don't have IR because instead we have Bluetooth. So we made room instead for the Bluetooth antenna, which is where the IR stuff used to be over here. And the nice thing about this is that you can still, do device to device, but you don't use IR, you use Bluetooth because we have central mode working. So this is that antenna coming down here, and we tried to kind of make it as far away as possible from all the metal bits. It has capacitive touch on all the pads, and it has analog on 6 of the pads. So A1, A2, A3, A4, A5, and A6 have analog inputs. But there's just not as many analog inputs on this board as the SAMD21, so TX and audio are not analog inputs. So you still get plenty, but not as many. One nice thing about the 52840 is that it can do peripheral pin muxing on like almost any pin. So any pin can be a PWM output because there's no like only these pins can do PWM. Like any pin can do anything. So even though we mark these as I2C and UART, any pin can be anything, which kind of makes it neat for making hardware that you can attach on. You don't have to worry about like, oh, does this have a timer on it or something. You got the switch and the battery. You can charge it, sorry, you can power it over LiPo or AAA batteries, just like the Circuit Playground Express. Like the Circuit Playground Express, it doesn't do battery charging. We did that on purpose because younger kids shouldn't be using li-poly batteries. They're not safe for young users because they could crush them or damage them or accidentally put them in the wash. We wanted to make sure that we could run this off of AAA batteries, like our little battery pack. And so in order to do that and not damage the alkalines, we did not put a battery charging circuit on here. So that's on purpose so that people can safely use it with any kind of battery without accidentally trying to charge that battery and causing a little fire or battery meltdown. It's got fuse on it and the regulator, and yeah, you can program it right now with CircuitPython or Arduino, and hopefully we'll have make code coming shortly. So that's the Adafruit Bluefruit Circuit Playground.
Yes, yes, indeed, that is what it is. This week's product pick is the Circuit Playground Bluefruit. This is an NRF52840 based chip, but it's in the same Circuit Playground and Circuit Playground Express form factor that people love. It is a Bluetooth rather than infrared for doing communication between devices. But that NRF52840, that's a Cortex M4 chip. That thing is beefy. It can do a lot. You can code it in Arduino. You can code it in CircuitPython. You can code it with make code. So since that video came out a few years ago, make code support came along. You can go to maker.makecode.com to use that version. It's different than the adafruit.makecode.com that's just for the Circuit Playground Express. Some of the lovely features we have on this. Let me bring up this image here. I'll unplug that battery from there. So you can see what we've got on here. So it's round, it's friendly. It has all of these alligator clip friendly pads. You can also use M3 screws. If you get conductive screws, you can wrap wire around, screw them down with a nut, or you can attach them to some of our gizmos that are little peripherals for this, or you can just attach the alligator clips to them. It has BLE for wireless, range of about 75 feet to 30 meters that Lamore tested in the factory. 2 megs of SPI flash storage. It has the 10 neopixels around the edges, RGB LEDs. It has a LIS3DH motion sensor, so you can do tap detection, fall detection, orientation. We have a temperature sensor built on there, light sensor, sound sensor, a little microphone. There's a mini speaker built right on. As far as input, there's a little slide switch. There are a couple of buttons. The alligator clip friendly pads on the sides there, I believe 6 of them, maybe 8 of them are cap touch friendly. So you can use those as extra buttons without needing physical mechanical switches. And it is USB for power and data. It's a micro USB cable. The battery power on the bottom is a little JST-PH connector, which you can use with a little alkaline style battery pack like this. Often these have a little on-off switch on them, which is convenient because the Circuit Playground does not have its own on-off switch. Or you can use a LiPo like I showed before, but as Lady Ada said, this does not have a charging circuit, so you'll need something else to charge your LiPos. Let me go to the Learn Guide here. Well, here's the product page actually. So on the product page, you can see here, this is wild. We have this for a song. It's $12.48 right now. The great thing about this is that if you want to introduce someone to coding for microcontrollers, this is perfect because you can code in a bunch of different languages, like I said, and you don't really need to do any breadboarding to have access to a whole bunch of sensors, a whole bunch of input and output, including sound, including light, including the motion and orientation. So this is a really popular one in classrooms. You can scroll down here and you'll see we've got a link to the Learn Guide down here, as well as there's a link for, there's so many guides about this, See All Guides. So let's go there first actually. If you go to See All Guides, you'll see some of the projects here are pretty instructive, things that you can do. You can code it remotely. We have Bluefruit wireless coding. You can get into the directory and code in CircuitPython wirelessly. There's Bluefruit LE Connect for iOS and Android, which is an Arduino program that allows you to use your phone as a remote control. Let me take a question from the chat. Ruben B4 says, I'm confused about the micro USB. Would this have any advantage over USB-C? No, I like USB-C a lot better. However, this was meant to be exactly compatible with the other two Circuit Playground boards, and this injection molded case here is a real beauty. It happens to be micro USB only. You could probably file that out, and if we ever switched to a USB-C, but since this case exists and existing projects that were using micro USB, Lamar decided to keep that on there. But I agree with you. I'd love to see a revision in the future with the USB-C. Good question, Ruben B4. Thank you. Other projects you see there, we've got Bluetooth connection to devices like a computer, laptop, mobile device that you can use for things like HID. You may have seen a week or so ago, I did a remote camera shutter for iOS using a Circuit Playground Bluefruit because it can show up as a Bluetooth device, BLE device, and send keyboard commands and consumer control commands over the air. You can also do device to device. So we have client and peripheral, which is a typical way that Bluetooth devices are ordered in a hierarchy. We can use that so that a couple of these can communicate with each other, more than a couple. There's even proximity sensing. One of the projects you'll see if you scroll in here is a hide and seek game that I built a number of years ago, which I had forgotten about until I started looking at, here we go, Bluefruit Playground Hide and Seek. You can have a couple of these decide which are the closest pair and change your lighting or other things based on that. And on and on and on. So check this out. If you just go to the main product page, see all guides. Here is the Learn Guide. So we've got info here on updating the bootloader, putting CircuitPython on, putting Arduino on, like I said, maker.makecode.com if you want to use visual programming and no actual typing. Then there are examples in CircuitPython Playground, which is a sort of high-level library that puts a whole bunch of commands under the same roof. So it's very easy to say things like use the playground button A, button B, sound out, analog in, cap touch, driving your NeoPixels, reading the different sensors on there. All of that can be done in CircuitPython, or you can make it even easier with this playground library. So here's some examples here for that. And we also have Arduino examples, BLE examples there. So tons and tons of stuff out there using this particular chip. NRF52840 from Nordic is a terrific chip. I wanted to show you a few different demos now. So let's go to a downshooter cam here for a moment. So here is an example of client and peripheral. By the way, these little 3M Post-it notes, I think these are 3M, the little square ones, they fit really nicely as a tag if you're trying to remember which one is being used for what in this case. So I'll power up, let me do the power there. So I'm powering up my peripheral. I'll grab this LiPo and power up the client. These are now going to connect to each other, so the peripheral just connected to the client. And you'll see if I hold one of the cap touch pads, I'll get a little red LED circle flowing around. I'll get a green one with this pad. I'll get a blue one with this pad, and I can also mix those. So if I do combinations of those, I'll get little swirling patterns. So that's all just device to device using Bluetooth LE, which is really neat. Let me show you another example of some of the features on here. So this is one, by the way, one thing I really love about this case is it has threading, 1/4 inch 20 threading for tripod mounts. So you can screw that to any of your tripods or just get a 1/4 20 bolt or screw, connect that. This one needs power. I'll just plug in USB power. So here's a little micro USB cable. And I'll just adjust the focus. Whoops, over here. There we go. So you can see with this case, we can still access the switches, buttons, and I'm gonna go ahead and restart this one. So what I've got going on here, if I press one button here, I'll switch the LEDs to blue. The button B sets the LEDs to yellow. If I move my little slide switch here, I have some big gumball style 10mm LEDs that I have just literally wrapped the legs around ground and an output pin. Same with this one. So that's a really nice thing about this, is that in a learning environment, you can get away with without needing a lot of fancy supplies, and you can kind of just wrap things and clip things and use alligator clips and screws and things like that to connect up. So the other neat thing is with these alligator clips, we have some alligator clip to 3.5mm mono jacks. And so to that, I've connected a foot switch. So if I stomp the foot switch, you should hear a little sound, a little bleep, bleep, bleep. And that's one of these little foot switches. I think we have these in the store. And so if you're doing assistive technology, a lot of the times these 3.5mm TS mono plugs and jacks are used. So you'll find a lot of stuff can be connected, which again makes it really easy to swap things in and out. And in this case, I adapted the pedal using one of our little screw terminal based. This one happens to be TRS, but that works just fine in this plug here. So that all there was done in Make Code. So let me show you some examples of code going on here. First of all, let's take a look at just a color swirl. So I'm going to plug in this first one that I had on here. There we go. That's going to show a nice little color swirl there, which always looks better if you can have that light bounce off of something. I'll set that down there. And let me head over to Z. So this one's in CircuitPython. It'll show up as a CircuitPy drive, which is what I just opened. And let's see. Oh, wrong drive. That's my that's my Fruit Jam. Where's the other drive? There it is. This can get confusing. So this one was something Phil wrote actually back in 2021, and it is just a nice color wheel demo. We actually ship this device, I believe, with Arduino and a color wheel demo. So I think Phil wrote this version for CircuitPython. All this needs is time, board, which imports all of those board definitions for all the pins. Rainbow IO, import the color wheel, and NeoPixel. Set the number to 10, instantiate the NeoPixel ring built in, which is just on pin NeoPixel, board.neopixel. And then this is a variable for whether we're running that demo or not. We are. Here is the demo function. So it just loops through 255 color values in a hue saturation value or hue saturation brightness color mode, and sweeps through that over and over with the little wait time. If true, then we just run this with the wait time of 0.5. So that's real simple example there. If we take a look at this, this one here, I'll power this back on. And let me set up let's do this window over here. That should work. No, let's do it this way. Hold on. I'm going to fiddle around here with the video layers. Hide that. Okay, so we'll put a little me up in the corner there. And if I go to maker.makecode.com and let's see, import, let's try that. Import file, choose file, and I'm going to go to my Circuit Playground current UF2. Go ahead. Will that work? It will. So that just opened the UF2 file that was sitting on here. So I'm going to get out of bootloader mode just so that it starts running it again. And so this is the visual code that I have running on here. Let me move some stuff. Whoa. Move some stuff around here. There we go. And I can get rid of this. Whoop. Okay, so what happens? On startup, where'd my on startup go? On start, this green block here, I'm setting all the pixels to red. If I shake it, we set them back to red. So I forgot to demo that. If I go to yellow here and I want to get back to red, I'll just shake the Circuit Playground. The list 3DH on there is detecting a shake motion. And there are a few different motions you can use: tilt up, tilt down, tilt left, tilt right, face up, face down, free fall, 2G, 3G, 6G, and 8G accelerometer values that can be read from there. These are the button A and B presses, which I think on this the buttons are always. Oh no, they're not backward. For some reason I thought these were backward. Okay, so left button here, button A sets it to this amber. Button B sets it to blue. On button A2, which is just simply me connecting a ground and to pin A2 here, if I just short those, it'll beep, but that's what my hands-free clicker is doing there. And then this is the switch detection. So if I go right, we turn one of these LEDs on and the other off, and vice versa if we go the other direction. So that's just a little throwback there to some MakeCode. I haven't done MakeCode in a while, and I forget how perfectly enjoyable it is for putting down your code just based on logic. So that is a really nice feature of this. So let's see, what else? Let me go to the Discord here for a moment, see if there's any questions. Sam J. Ohio says, may I recommend this product for anyone considering buying the Circuit Playground, which allows you to easily connect to I2C? Thank you so much for saying that, because I forgot to mention, you can, of course, do I2C, which opens up a whole world of possible sensors, displays, OLED, little mini OLEDs, input and output. We have a whole ton of stuff that we call our STEMMA QT, often our STEMMA QT devices, but this is this product that Sam has linked to here. I'll go ahead and open that up in the browser. 1 second. Copy link address. Bring up browser. Paste that in. These are Alligator Clip on one side and STEMMA QT on the other, which allows you to plug STEMMA QT right into all the little great STEMMA QT boards, and then you'll clip those four to the serial clock, serial data, power, and ground on Circuit Playground Bluefruit. So that really opens things up a lot. Thank you for that. So let's see, over in YouTube, no questions? Good. All right. And Yanisku just posted a cute little GIF I forgot exists, this little Circuit Playground right here. It's fantastic. So that right there is going to do it. Don't forget, head on over to that URL right there. It's product 4333. If you want to pick one up, or 10, we have plenty in stock still. And let me go ahead and wrap this up. I'm going to swipe a battery here. This is, I like these little, these 500 or 350, yeah, little 350 milliamp hour LiPos are nice. You can stick them to the back there. Also, by the way, these boards do have a little name tag on the back. So if you're using these in a workshop or a camp or a school setting and people are gaining possession of them, at least for a while, you can put a name on there. All right, that right there is going to do it. That is my product pick of the week this week. It is the Circuit Playground Bluefruit. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you soon. Bye-bye.